This is the Kratom Science Journal Club with Dr. Jonathan Cachat, neuroscientist and expert in psychopharmacology. In each episode, we discuss an article in a peer-reviewed journal. I'm your host, Brian Gallagher, blog and social media writer for KratomScience.com, your source for all things Kratom. Episode 5, we discuss assessing physiological dependence and withdrawal potential of Mitragynine using schedule-controlled behavior in rats from the journal Psychopharmacology. Full citation in the description. The study concluded Mitragynine does not induce physiological dependence and can alleviate morphine withdrawal.
So an interesting paper this time around.
Yeah.
Certainly.
There's a lot of weird stuff in here, and I like that rat video. It kind of, I was trying to picture it in my head when I was reading the study, but that definitely helped. Have you worked with rats before?
I have rats and mice, but that was more of like a lab course class during grad school. But zebrafish are mentioned in here, and if you look at that paper on what that paper was on zebrafish when they used Mitragynine, which by the way, I'm totally cool with switching to MG and just keeping it there for the rest of our episodes moving forward. But if you go to that zebrafish paper, my name's all over it. They cite my name for the behavioral tests, and so I spent a lot more time developing the behavioral models, or like translating essentially the endpoints that we used in rodents to fish.
Yeah.
And, to be honest, when I think about what we were doing with the fish compared to what they did here with the operant conditioning. So, operant conditioning is basically just a behavior that's reinforced. It could be positively or negatively reinforced. And so in our case, we had rats who were only getting 85% of their diet. So they were kept hungry in their home cages. And then they would go to the experimental room, they would get an injection, and then they would go into these operant chambers. And basically, there's a whole phase at the beginning there. I think it's called the shaping phase, where, the rat goes into the box and they press any button, they get a piece of food. But eventually, after doing that over multiple days, you start to change it so only one of those levers works, the right lever, and you got to press the right lever 10 times in order to get the food pellet to come out. So once the rat has demonstrated that he understands that, like where, you drop him in the operant chamber and essentially he goes right to the right one, doesn't even look at the left one, presses it 10 times, gets his food pellet, that the behavior has been learned. It's basically instilled, or as they refer to it in the paper, as stabilized.
Yeah.
So the indication of dependence or withdrawal was interpreted from a modification of that behavior, meaning they would, yesterday they went into the operant chamber and they were pressing that right lever 10 times, just like they did the past 6 days before. No joking around, right to the lever, get the food pellet. You give them the morphine, give them Mitragynine. If the drug caused dependence or induced dependence, or if the animal was in a withdrawal-like state, it would have reduced the response time, or the number of times they pressed that right bar in order to get the food pellet. And what started me off on this is compared to, especially zebrafish, but I don't know how good of a proxy that particular behavior is for determining like a withdrawal-like state or physiological dependence. Are you following me?
Yeah.
For example, we did the same exact studies in zebrafish where we gave them morphine for 2 weeks, 2 times a day, and then gave them a shot of naloxone before we put them into the novel tank, a tank that they haven't been in. It's just like putting them in the operant chamber. So we would induce withdrawal after giving them a chronic exposure to morphine. And with zebrafish, you're looking at their movement. So we're looking at the amount of time spent at the bottom of the tank versus the amount of time spent at the top of the tank. We're also looking for erratic movements. So fish, when they're in a highly stressed out state, they just swim like crazy. Like, it's just unorganized. sort of just flailing around. Very clear. You can see it. And then we would also, after that, extract cortisol, or the primary stress hormone, from all those zebrafish to see if it was elevated, because it would be an indication. Then we would have a behavioral indication of withdrawal. Like, you can see that they're freaking out.
Yeah.
And we also had a physiological biomarker of an increased stress response, namely it increases levels of cortisol. And I just feel like, you know, I feel like that's a more comprehensive approach to understanding dependence or withdrawal.
Yeah.
But that doesn't, I guess it doesn't mean that this one isn't valid. It just means that I feel like there are better animal models to assess that particular phenomena.
Yeah, they didn't do a cortisol test, I don't think, unless I missed it. Okay.
No. Yeah. The only endpoint was changes in that conditioned behavior of pressing the right lever 10 times to get a food pellet. Yeah. That was the only endpoint they had.
And what's the reason for the naloxone? Because I know with humans it's Narcan, and that's the stuff that you give somebody if they're having an overdose. What does that do? Because I know they gave morphine. One group got morphine. One group got mitragynine. Then they were given Narcan, and then they were tested for... Yeah, they were given Narcan.
Right.
Or naloxone. So what does that actually do?
So I'm going to just explain quickly the first two phases that they did and then end with the naloxone one. It'll just make more sense that way.
Okay.
So the first thing they were doing was looking at the acute effects of morphine, mitragynine, or the control or vehicle, just no drug, but saline, the acute effects on behavior. So they wanted to know, after the rats have stabilized and learned that pressing the right button equals get your food, if we give them drugs 30 minutes before they go into that operant chamber, is it going to decrease the amount of times they press that button? So a change in the learned or operantly scheduled behavior. Okay, so that was the first one. Acute exposure. If I just take a morphine or I take mitragynine, does it affect me immediately in some way that's behavioral? I guess is the best way I would think about it. And so what they found was, with mitragynine, there was not a significant reduction in that response behavior compared to the controls. It looks like it sort of maybe dipped a little bit. They all dipped, even the control one dipped. But then the morphine one basically like hit the bottom of the graph. It dropped immediately. And so, you know, I think I'm going to put an asterisk right here, because I think it would be interesting to discuss why this behavioral test is a proxy for opiate abuse, because it works with opiates, but I want to dig into there. So after they looked at the acute effects of behavior, they wanted to know, okay, are there indications of physiological dependence? So they're going to get all the rats back to stabilized, meaning they know when they go in the box, they're not taking any drugs. They go like 10, 14 days where they get it stabilized to where they get in, they go to the lever, they press it. So everybody's stabilized now. Now we're going to inject you 2 times a day, every day, for 2 weeks with either morphine, mitragynine, or the vehicle.
Yeah.
And then we're going to give you the naloxone, so inducing withdrawal with naloxone. So what that does, I'm sure, you know, our audience has heard the stories, and maybe even some of you guys have seen it yourself. I don't know if anybody's in law enforcement listening, but essentially in the ER and out in the streets, I suppose, when doctors or law enforcement officers give someone in the middle of an overdose Narcan, they wake up and they're pretty agitated. They're pretty pissed off. They were, you know, in a bliss of an opiate blanket, and then all of a sudden they were just sort of ripped out of it immediately. So essentially, that's what we're doing to the rats. We're getting them used to the sort of the warm blanket of opiates and that for 2 weeks, taking it twice a day. And they had a bunch of different doses, a low dose and a high dose. And then 30 minutes before they go into the operant chamber, we're going to induce withdrawal. We're going to inject them with the naloxone. The naloxone is going to get in their nervous system. It's going to kick off all of the morphine or presumably mitragynine molecules from the opiate receptors and bind to them immediately. So the effects of the opiates is just ceased immediately. And it's a way to induce withdrawal.
They had like a washout period, and then they gave them rimonabant, which is an inverse CB1 receptor agonist. So do you know anything about that, or what does an inverse CB1 receptor agonist do?
So, yeah, it's a CB1 agonist. They use it to modulate appetite, I'm pretty sure. I think it's a weight loss is the official approved use. Interesting to note, too, United States, I think, is the only country in the world that allows this stuff to be prescribed to humans still. I know the European Union blocked it a long time ago. So what they were trying to do, and I want to pull up the paper just to make sure I get it right, but it seems to be that there was an indication in the literature that using this cannabinoid on animals that have been chronically treated with an opiate causes the same effects as essentially a naloxone shot, in that it competes with or diminishes the intensity of the opiate activity in the brain, leading to a reduction of feeling that drug. What I think that they were trying to really understand, and the point they were trying to make, was we do know, and I would not disagree with the fact that the cannabinoid system and the opiate signaling system are pretty tightly intertwined and can affect and modulate each other. That's primarily because the CB1 receptor sits on the receiving neuron, not the sending neuron. And so the sending neuron is shooting molecules into the synapse, that space between the two neurons. And once that receiving neuron starts getting those signals from the neuron upstream, cannabinoids start going out, getting released, going back to the sending neuron to basically say, like, got the message, settle it down, we're good. You know, it's called a retrograde messenger, and it basically calms down signals from happening. And so I don't know if I've seen enough evidence that would allow me to competently support the idea that this CB1 cannabinoid receptor agonist, rimonabant, competes to the same degree in inducing withdrawal-like symptoms as naloxone. And what they end up finding when we are looking at the use of mitragynine or kratom alkaloids as an opiate substitute, so sort of the third phase that they investigated, was that, you know, we'll give them morphine for 2 weeks, we'll give them naloxone, and then we're going to give them mitragynine to see if that counteracts the induced withdrawal. You know what I'm saying?
Yeah.
Yeah. So give them morphine for 2 weeks, induce withdrawal with a naloxone shot, then give them mitragynine right then and there, 30 minutes before they go, with the hypothesis being that if mitragynine can alleviate some of the behavioral, physiological symptoms of opiate withdrawal, then the animals that received mitragynine would not demonstrate a decrease in their responses inside of the operant chamber. But those that were given, and the other one they gave people was Suboxone, or the rats was Suboxone.
Yeah.
And basically what they saw, I think, was that not only did mitragynine attenuate or lessen the severity of those withdrawal symptoms, it resulted in not having to use as much of the Suboxone, but it was also paralleled by this cannabinoid.
Yeah, it says, although more work is needed, these data suggest that cannabinoid receptors may be involved in the development of MG physiological dependence, and therefore may represent the neurochemical basis for MG or kratom abuse and dependence liabilities.
Well, they were also separating the notion of developing physical dependence or tolerance, right?
Yeah.
They started getting into a talk about like they were distinguishing between two different stages of establishing physiological dependence, and I think that what they were essentially saying was maybe like morphine sort of activates and immediately starts heading down the path of physiological dependence. But there's something different about mitragynine and the kratom alkaloids in that it doesn't lead to a reduction in the behavior they were using as a proxy for dependence.
Yeah.
So like the behavior didn't change, but the ability to correlate the environment with the withdrawal or the potential withdrawal, maybe there was a disconnect there. So there's two very like sort of nuanced stages where, you know, first you learn it, and then after that you sort of embed it. And they were saying essentially that maybe kratom doesn't, the kratom alkaloids don't immediately induce dependence like morphine does, but very clearly, that it doesn't lead to changes in behavior, and it's different somehow. And I really, you know, I think that it sort of becomes apparent in sort of the narrative I think that they're laying out here is that, and it's something that we've said many times, is that these are a novel class of compounds that we don't fully understand. And, you know, there's a lot of times where in this article, they're sort of like, well, we got this result, and, you know, there was no significance in this data. And that's what we got. And so it sort of goes along with what these other studies have shown, but it also sort of goes with the studies that were, you know, suggesting something completely different, which is, of course, always happens in science, but which is, I think, just an indication of the fact that, you know, doing more studies like this to try to tease apart those nuances is going to lead to better approaches, especially what she's talking about in this paper, which is essentially approaches to treating opiate use disorder.
It talks about the response rate. Is that the rate of how many times they're pressing the lever for food?
Well, so it's the response rate at a percentage of control. So the animals that didn't receive any of the drugs, just received the vehicle or the saline, they took their response rate and then sort of averaged everybody else's response rate to the control. So it's percentage change from control. You'll notice that the axis goes from 0 to 100. So the bar is where the control animals were with no drugs. So they're illustrating the effect or the difference or the variation of the drug treated animals from the non-drug treated animals.
They did 2 experiments. In the second one, that 2 groups of rats both got morphine, and then they tested how whether the buprenorphine or mitragynine would the different responses in each group. Like one group was given mitragynine.
Yeah.
So it said in that case the mitragynine group increased response rates, and then the buprenorphine didn't. So I was just wondering if that, you know, shows that morphine withdrawal symptoms are less severe when they're given mitragynine. So
yes. That is the right conclusion, and I believe you're talking about Figure 5. And so Figure 5B, you can see that the morphine-treated rats who were given higher doses of mitragynine, the line goes up. So their mean response is increased, meaning mitragynine alleviated or attenuated or reduced the impact of withdrawal-like symptoms better than Suboxone.
So another thing this brings up, and I kind of brought it up in my article, was they gave them 98% pure mitragynine, and it also mentions, and I've heard this before, that the 7-hydroxymitragynine might be the stuff that actually causes a little bit of dependence issues and maybe has bigger opioid-like effects. So would this study maybe be used to make the case that mitragynine should be extracted and used as a medicine on its own, separate from the kratom plant?
So that's interesting. So it wasn't like a powder was injected into the rats. I just want to make sure we're clear on that first. So it was, you know, it was mixed into a saline solution, and then and then injected, right?
Yeah.
So it wasn't like they were, I don't think that, you get visions of sort of like Scarface sitting there, right? Like, oh, they got 99% pure Mitragynine, that's different than the plant. But I agree with you in that it is. And the note that I wrote down about that, the author of the paper basically said at the onset that there are therapeutic issues that need to be worked out before we could start using Mitragynine or Kratom in like an official therapeutic setting. In that, we need to know whether or not there is a liability to induce physical dependence, as there are with all opiates. So it's sort of just silly. It's silly to say, oh well, if Kratom is going to be a good treatment path for opiate use disorder, it has to have no dependence or tolerance liability, because Suboxone does. I mean, all of the opiates that we do have now are the same thing in terms of how they're received by the body. They might last a little bit longer, but they're the same thing. Whereas the Kratom alkaloids are not the same thing. And you're right, they did make a distinction saying that it seems to be reported in the human literature, as well as some other studies that were done, that the 7-hydroxy is more powerful, and that may be to blame for development of physical tolerances or dependence. But they didn't give them any. But the other thing that worried me about what you said, well, if we want to make this a therapeutic, we got to eliminate the dependence liability. Essentially, we don't want to get them hooked when we're trying to treat them for opiate use disorder. Just getting there would be a better step from where we are. You know that. But one thing no one ever mentions here, and I think it's something that I've said on the podcast before, is based on the method of administration. And so my worry is that, and it's inevitable that it will happen, but if we were to essentially get Kratom in a pharmaceutical pill, it would lead to a situation where people who are trying to get off opiates would essentially just be like they are now, in that, okay, now you're taking that pill for the rest of your life. Suboxone. You're just gonna be taking Suboxone every day. It's better than the risks associated with sort of IV use of heroin, right? But it's still the same thing. And I feel like when drugs get extracted down to one compound, get pressed into a pill, and just become something that you can toss in your mouth without even really thinking about it, it becomes a lot more, I want to say convenient, but it's almost too easy for someone trying to transition out of, an opiate problem. And that if they recognize the fact that if the method of administration gradually deters you from continuing to use what you were using, at the beginning, you're like, I just don't want to go through opiate withdrawal. I've been there. I don't want to do that again. I'll eat as much plant matter as you got. It's better than going through this. But then 2 or 3 months later, you've sort of, found your way off of it. And then at some point, the notion of consuming that much plant material becomes sort of unappealing or a pain, or you spilled the Kratom powder on your wife's counter and it made a huge mess. And, it turns out to be not worth it as much as it was when someone was at that sort of delicate transitional state. And that's that in and of itself, I guess is what I'm trying to say to summarize here. That in and of itself is a way to sort of protect against a dependence liability. Make it not as easy and convenient to consume quickly. Method of administration also goes into that, that play. Yeah. That discussion.
Yeah, they did mention something. It was a different point that you just made, but it says because the rats were given intraperitoneal injections, which I think is the abdominal lining, because I looked it up. But it said the difference in route of administration would yield different rates of onset of drug effect, drug levels, duration of effect, and metabolism. So that's kind of a different point. But they did mention something about that, and also the fact, that humans consume 1 to 5, according to some of these studies, 1 to 5 milligrams per kilogram of Mitragynine when they consume Kratom. Rats in the study sometimes got 50, and then they even actually mentioned that a rat from the study. I didn't find it. It was like from 1972, so I don't even think it's online. But
yeah, Mako, 1972.
Yeah, they said a rat got a dose as high as 806 milligrams per kilogram, and it failed to produce any toxic effects of mitragynine. So that was pretty interesting to me.
Yeah, and you know, you're right in mentioning they did acknowledge that the way that their method of administration could have led to some differences when you try to translate it up to humans, and that, of course, especially with opiates because of first pass metabolism. So it wasn't going through the rat's digestive system. It was just sort of getting injected into the body cavity, and so that could lead to some issues. But they also, I mean, that whole discussion where you ended about the 806 milligrams per kilogram, you know, there's a big section here where they are sort of trying to make sure that they were giving the rats what is called a human equivalent dose. Okay. And there were, you know, I think she mentioned 3 different studies and the ranges at which the people self-reported how much they took. And then you realize that they had no idea what the content of mitragynine was in those, not let alone how much tea they drank that day, right? It's just a completely inaccurate way of understanding different dose responses, if that's what you're interested in doing, what they're doing here. But they were trying as best they could to match what would be a human equivalent dose, why it's reduced down to milligrams per kilogram. And just to put that into perspective, this 806 milligrams per kilogram, I don't know, you know, I don't have a good sort of just ballpark estimate of how much of a kilogram is and what that relates to like humans or rats. But essentially, one of the extracts that you can get, the liquid extracts of kratom, are usually, you know, between 100 and 250 milligrams of alkaloids. So that would be equivalent to taking four of the 15 milliliter extracts all at once. And, you know, I don't know. I don't know how the rats were even seeing straight. I mean, they had to have gotten the wobbles, but it is interesting because I feel like a dose of morphine that high would have definitely led to respiratory depression and death. But with mitragynine, you know, an absurdly high dose did not cause death, at least. That's all I say, is that failed to produce any toxic effects. And it's crazy that it was in 1972. This guy Mako was so really way ahead of the ball.
Yeah, I couldn't find it, but yeah, I wouldn't mind reading that, just because that's
It's called Some Observations on the Pharmacology of Mitragynine. Maybe we should do that next week. You know, do a little sort of retro or looking back episode. Since this is such a new paper that came out that we're doing today, it'll be interesting to see sort of how he tees up everything. You know, like it was real easy for the researchers in current times to say, oh, well, you know, there's a public health issue. Like all scientific papers start out, there's a public health issue that we need more options for, so we're doing this. What was he doing in 1972, and how did he even know about kratom back then?
So the conclusion is weird, and because I know some people would look at this study and say, okay, this means kratom isn't addictive. And I'm a little more careful than that. I mean, because it's one study, that doesn't mean it proves anything beyond a reasonable doubt. This conclusion says, the findings suggest that MG does not induce physiological dependence, but can alleviate the physical symptoms associated with morphine withdrawal, which represent the desired characteristics of novel pharmacotherapeutic interventions for managing opioid use disorder. So is this the same thing as saying mitragynine does not cause physical addiction? And if not, what's the difference?
So great question. And and I appreciate the sort of hesitance to, you know, run out and start doing, you know, shouting to the moon that it's not as addictive. And it sort of jumps back to what I was mentioning earlier, wherein why does a reduction in the amount of presses on a bar after 30 minutes after getting injected with an opiate tell you anything significant that has translational value to human behavior versus if you were to do like some sort of other stress test. Like you could put a rat, you could get like the scent of a dog or a fox, right? One of the predators of the rats, put that in their cage and just they would freak out, right? There's other ways to sort of induce stressful situations. So why did they pick just this bar one? Well, we had morphine, right? And we had rats. And when we gave the rats morphine and put them in this box, it led to an enormous reduction in the number of responses. So basically, I guess what I'm saying is that how confident can we be that this is actually an indicator of physical dependence or withdrawal versus being just a sort of phenomenon that happens when you're given a classical opiate, right? It would have been great if they had physiological measures like cortisol measurements. Then at least you'd have some sort of biomarker to go along with the behavior, and then you could be a little bit more confident. But back in the day when they were developing these tests, and to a certain extent, it's what I was doing with the zebrafish, no one had given all of these controlled substances to zebrafish and sort of indexed and characterized their behavior in a novel tank. So that's basically what my graduate thesis was, the full sort of exposition of this is what all of these drugs do, and this is how they're different, and this is how they're the same. When they were making this operant conditioning, holy shit, morphine every single time across the board causes a reduction in the mean response rate compared to the rats that didn't have the morphine. So to go back to your question, is it fair to say, what is fair to say is that whatever is happening with mitragynine and the alkaloids in kratom, it's different than what is happening in classical opiates. So like, morphine, heroin, the hydrocodone, oxycodone, all the Suboxone, all the ones that are out there.
Yeah.
So it's if you wanted to be conservative, it's really difficult to say anything definitive beyond that. We just know that it's different, and we know that it's different because it is seemingly, and they mentioned this in the paper, it's seemingly everyone who uses it and reports, the studies that are out now about human reports on the effects say, I use this for pain reduction, or I use this to help get through opiate withdrawal. So very quickly, and you see this with all the sort of political hysteria on banning kratom, they said, oh, that's an opiate. Well, we can't have that. We can't have just opiates running around willy-nilly. What this paper demonstrates is that the mechanism of action of mitragynine is different from that of classical opiates, while also having an overlap in the effects that they cause, namely pain reduction and activation of the opiate receptors. They were saying one of them, and I think that morphine binds to the mu opiate receptor, I think, like a glove, right? Those are like the first two things we knew. Morphine out of poppies, and and then we found the mu opiate receptor. There was a sentence or two, and I don't know if it was cited, and I didn't go dig deep on it, but what they were saying, I think, was, and it might have been even the difference between 7-hydroxy and mitragynine, in that one of them, while it does bind to the mu opiate receptor, its primary, or where it binds stronger, is in the kappa, or the is delta or kappa, one of the other ones. And so it seems to be, according to the behavioral results of this study that we're reviewing, that distinction or that difference alone could lead to different dependence, physical dependence, or withdrawal, severity of withdrawal, like manifestations, if that makes sense. Like just that little difference is showing up in these behavioral tests that are evaluating dependence and withdrawal.
Yeah, and it binds to that receptor differently than classic opiates, right? Because it's or mitragynine and 7-hydroxy bind to the same receptor, but not in such a way that produces the like the respiratory depression, I think. So
it's the one we talked about.
So just because it binds to it doesn't mean it does the same thing, basically.
Right. Yes. Yeah. Just because it's binding to that receptor, Doesn't mean it's doing the same thing. And I think there's indication that, we've talked about the recruitment of other cell surface signaling molecules once a receptor is activated. We know that the classical opiates induce that activation of the secondary proteins within the cell wall and lead to the envelopment of the receptors back into the cell, or reduction of receptors overall, and therefore tolerance, or having to take more to get the same effects. We know that Mitragynine doesn't recruit those secondary molecules, right? So that's a distinction in and of itself too. And you're exactly right. Just because it binds to the same receptor doesn't mean it does it in the same way. It's where the old lock and key sort of analogy of that, the key is the opiate or the signaling molecule, and the lock that you stick it into is the receptor molecule. It breaks down because in reality, you can stick a bunch of different keys in the receptors and they'll lead to some level of activation. I don't know if they're going to open the door, but you're going to know that it's in there. And we just don't know very much beyond that. What was sort of interesting for me, seeing how, number one, how well developed the extraction and isolation of Mitragynine protocols have come. When we gave it to zebrafish in grad school, I could only find one paper in published scientific literature that had an extraction protocol in order to get the active compounds out of the leaf into some sort of isolate. But it was in Chinese, and despite my best attempts at emailing the authors and the publishers and the journal and everything, could never get my hands on it. So that's developed, quite significantly. What we did when we gave the zebrafish the kratom, or exposed them just to see what would happen, is we ended up just putting them in kratom tea and letting them swim around in it for a while. Brewed it up and then let them swim in it. I mentioned that because it was because of our inability to extract it. At Tulane Neuroscience Department, there's an entire lab dedicated to trying to find pain management drugs or a target of drugs that is, like you said earlier, doesn't induce the respiratory depression, which is what people die from, but then also doesn't induce physical dependence or withdrawal-like symptoms, or the liability or severity of that tolerance development and physical dependence is much less. And they essentially, within the pain management research community, they call that the holy grail, the goose and the golden egg. If you can figure out how to reach pain management effectively physiologically, so it actually does help with pain management, but it doesn't induce dependence, then you have essentially, found a workaround about the biggest problem with the, humans' longest approach, pharmaceutical approach to pain treatment in opiates. And I remember having conversations with this professor whose lab was a floor down from ours, saying, you got to look into this kratom. You got to look into this. This is, and they acknowledge it in this paper too, because they essentially say, there's plenty indication that kratom can be used as a substitute for opiates, especially if you're trying to transition off, namely because so many people are doing it, it must have some effect, right? It must have some benefit. But we never could isolate it, and we can never get it into his protocols. And I almost want to reach out to him now and just say, hey, did you get over to the, kratom alkaloids yet? Because that's where everybody's pivoting.
Yeah. Oh, that's awesome. That's it's pretty exciting.
It is.
Yeah. It's just interesting that just some of these results have coincided with stuff people told me, especially I pay attention. A lot of people have, they try to get off heroin and other stuff with Suboxone or buprenorphine, and then these studies suggest that, the kratom helped me get off the Suboxone. So there it is right there in the rats where they didn't show withdrawal symptoms having Mitragynine after Suboxone. So it's pretty cool. Or the amount of Suboxone you needed to take in order to get a similar level of release is lower, right? So of course it would be able to help transition people off Suboxone. The other thing is
Suboxone is a long-lasting opiate, buprenorphine, with naloxone. So you take it with Narcan. They're 50-50 in the pill. So the idea is essentially that you take them both at the same time. You're not going to get too much activation. You're not going to get too much like rejection of activation. You're just going to be sort of right in the middle, right? Just to sort of keep, you know, you're not going to go too far to the left. You're not going to go too far to the right. It just is. I feel like if everybody were to step like 3 steps back and then look back at the problem and say, we're currently treating the people with opiate use disorder with opiates and Narcan, and they just take that for the rest of their life. You know, it's crazy for me to sort of wrap my head around that. But, you know, I guess in some ways too, it just speaks to maybe how unique the opiate compounds are, right? And how valuable they were and what they had done for us in our history. But we're now getting to the point, and studies like this, and one of the reasons why I was so excited to do this one is now we're starting to disentangle where the kratom alkaloids are similar and where they're different. And when it comes to the development of tolerance and the severity of withdrawal symptoms, there seems to be emerging a trend that kratom is not just another opiate. There are different things happening.
Thanks again, Dr. Jonathan Cachat, for another episode of Journal Club. We try to get these out every 2 weeks, so that means the next one will be October 1st. Kratom Science Podcast is on every week, and you can find that and other kratom news and information at kratomscience.com. The music is Captain Big Wheel, and the song is Moonrunner. All right, take care.